So today I would like to discuss with you two types of programming which we use. Well, there are essentially two types of ways we can do our programming. We can do declarative um, or imperative programming. Now, obviously, we're talking in context with into network automation on how we can do declarative and imperative type of style of coding um, um, in network. So just to give you a brief outline of what that is. So just a brief summary would be a declarative programming would be when we are essentially creating a function or and that will essentially try to focus on the end result, meaning that this function sole purpose is to try and focus on the end results, just getting the end result, regardless of what the how it gets the results. We are just essentially focused on that specific task, which is just to get um, the final results really, and we're not focused on how the code does this. We are just, I mean, our fundamental aim here is to try and make the code as short as possible, but also as direct as possible, by providing the code with just a declarative, aka as what it's called, a function which will, like I mentioned, is we are, it's. I'll give you a analogy in a second. An imperative, we are explicitly telling a function to to get the end results. However, we are specifically directing it to and how it's going to achieve that end result, if that makes sense. So on declarative, we're more focused on the end result. What are the outcomes? And the on imperative, we are focused on and we are directing the function on how it's going to achieve that final outcome. It's a paradigm. It's a programming paradigm. Obviously, we're talking in context of network automation at the moment. To give you an example, analogy would be asking your friend to go into the store and get you an ice cream. Doesn't matter which ice cream, doesn't matter what it be, just get me an ice cream from the store. And that is what I'm focused on. That would be declarative. And imperative would be, if I was to say to my friend, say, I want you to get me an ice cream, but I want it to be this particular type of ice cream, and I don't want it, and I want it to cost this amount, is what I want it to cost. So what I'm doing on the latter is I'm actually focused with the end results, yes, but I'm also pretty much giving details on how he can achieve that end result. Where on the former declarative, I'm just focused on the end results, just getting the ice cream, if that makes sense. That's enough talking about ice cream, actually. Getting hungry. So yeah, so that's my that's a quick analogy really of what imperative and declarative sort of programming is. As you can see, I've got two examples. I've written two classes. So I'm just going to put my glasses here because I'm. So as you can see, we've got two classes here. The initial sort of class, the first class is a declarative. So I'm not too sure if you can see this in your monitor, but I hope it's that you're able to see it. So this is the declarative example. We are using again NetMiko module in order to do an SSH into the box. into the switch. I think we're connecting to a I could be wrong, but it's a, yeah, it's a 370x 3750x multi-layer switch. So we are going into that, and we are essentially setting the interface IP address. So we've got a class, a declarative class, and within that class we have attributes. So here are the attributes. So we've got an attribute for the actual interface that we want to target, and we've got an attribute for the IP address, and we've got the attribute for the subnet. So this is the class, and these are the attributes. These are class attributes. There is also something called instance attributes, which I'll get onto a little bit, but this is the class attributes. These are global attributes, so these attributes can be accessed from any other classes. And we also got a function in that class. So what we're going to do now is we're going to and that function, as you can see in that function, it's called set interface IP declarative example, and it's simply going to do is set the IP address to those attributes. So set the IP address. So the first thing we're going to do is just quickly check the router, because I may have done this already on the router, on the switch. So we're just going to quickly log into the switch. There we go. Right, okay, so you can see it, and see if I can make it bigger. Okay, so let's quickly log into the switch. And so enable, oops, password is, I just set a password, show IP in brief. So the interface that we're interested in is interface gigabit 45. So that's this one, that's gigabit. I'm just going to highlight it for you, 45. So it has already got an IP address there at the moment, as you can see. So it's got a 172.30.21 on there. So our focus is that attribute. So we're going to just quickly go and set it now. We're going to change it. So we're using the declarative example at the moment. So here's what we're doing. So let's change the IP address of the attribute. Let's make it something else. Let's go ahead with 111, all ones. 1 1 1, and we are going to now set this IP address declaratively on that interface. So let's go ahead and do that now. So I'm just going to run it. There, it's already set. Actually, let's just do it through here. I think it might be clearer, to possibly even better. So let's just do CLS, clear it, and let's just do it again. So here we are. We're going to just run it. Just running the script. Say a new IP address has been set for this interface, 1111. So let's just go ahead and confirm that now. Let's just quickly go back into the box. So show IP interface brief. There. So if we look at gigabit Ethernet 45 on this interface, an IP address has been set, 111 for that interface. So it looks like it's gone through okay. Right, now let's see, let's take the IP address off for a moment. Okay, so let's just quickly go into the interface. So conf t, if I can type today. Okay, so conf t, so we're going to go into interface, interface gigabit, Ethernet 45, and we are going to delete the IP address. There we go. So there. So it should be deleted. So let's just confirm that. Sure. Okay. Do show IP in brief. So as you can see, interface 45, the IP address of that interface has been deleted. It's completely gone. So it's unassigned. Okay. So let's go ahead and do another one again. Just to give you an example. So we're going to go ahead and do it again. We're going to set the IP address to be 11. Let's change it this time. Let's change it to 222. Okay, so now we've set it to 222 and it's going to go ahead and run that code. Let's just save it and let's go and set it again. So let's clear all this. Let's clear all this and we're going to go ahead and set that up now. There we are. Great, we've just set the IP address again. Now let's just confirm again. Do show IP interface brief. There we are. As you can see, just going to highlight that for you. Gigabit 45 222 has been set. So as you can see, we are focused on the end results, regardless of whether there's an IP address on there, regardless of it. So let's just set it now to 2299, and let's just do that again. So CLS, let's just clear this, and we're just going to run the Python code again. There, a new IP address has been set. Oh, sorry, we forgot to save this. So let's just save this script. Okay, so let's clear it and let's set it again. There, as you can see, we've got 2299. The IP address has been set on there. Let's just confirm it again on the interface, on the root, on the switch. There we are. So it's gigabit Ethernet 45, so it's 2299. That's been set. So that's a declarative sort of approach. We're not, we are essentially telling it, I want this change to change it. It's not going to look at any other attributes or so forth. So its main focus is to set that attribute regardless of how it sets it. It's just to look at, we're just focused on the end results essentially, and that's what we're focusing. So that's declarative. Let's just start again. This time we're going to quickly have a look at imperative and compare it. So no, so let's go. So no IP address, show IP in brief. Okay, do show, and this time, as you can see, 45 has no IP assigned at all address. Okay, so now that we've done that, we're just going to quickly block out this imperative, declarative code. So I'm just going to comment that out. So that's been commented out, so we're no longer executing. I'm just going to close this class, so this class is closed. So now we're going to open the imperative class. So here's the imperative class that I wrote out earlier. So as you can see, this is blocked out. So let me just take the comment out of this code. And we're going to go ahead and see what happens if we try to set an IP address. This time we're setting an IP address of, let's just say, 10.1.1.1. Okay, so we're going to go ahead and do that now. Okay, so we're just focusing on that. So let's clear and let's just try run it. There, new IP address has been set for this interface. Oh, it's still running the old code. Sorry, I forgot to save it. So let's just try it again. Save, and let's just go again. There. It's giving me a message this time, as you probably see. It says, sorry, the IP address has been set for this interface, and it's given me this following IP address. Now let's just try to find out why it's giving us this. So do show IP int brief. Got a D. Okay, so on 45, as you can see, an IP address has already been set from the previous command. So this IP has already been set on there. So let's just take the IP address again. So let's just do no IP, show IP int brief. There we are. And let's look at it again. This time it's gigabit 45. It has no IP set on there again. So let's set it again. So CLS. So let's see what happens when we are using the imperative approach again. So we're going to try and set it. It says here, this interface has no IP address set. Setting IP. And it looks like there's no IP address there. And it says new IP set for this interface is 2299. And that's the interface that we've set. Let's just have a look. Why is it interface 229? Oh yes, so it looks like it's getting the command, the module, the class attribute from the first class, the initial class that we've so the decorative class. So let's just have a look and see what we can change here. So we've got a interface IP address is being set. It never goes well when you're doing this live, so let's just go ahead and clear it, and let's set the so the imperative is here. Yep, so it's just basically giving us this sign. So it's all fine, really. There's no issues with it. The only thing I can do at the moment is let's just change this IP address, because it looks like we are getting all the attributes on there. I can change it on here. Let's have a look. So that's absolutely fine. So let's just change it to 10, 10, 9, 9. And let's go ahead and do it again, and see what happens. Sorry, the following IP address has been set for this interface 2299. So it's, if you notice what's happening here, it's now no longer concerned with just the end results. We no longer are just pushing configurations declaratively. We are now imperatively telling it how it should set that function, or how it should utilize that function. So we are guiding the program along on exactly how it should go ahead and set that function. So let's just quickly go through the class itself, the imperative class. So as you can see, similar thing again, we've got attributes, we've got the class name here, we've got the attributes, and we've got the function. Now this function, what it's doing is actually checking the IP address to see whether the interface has already got an IP address. If it's unassigned, if there's no IP address on there, it will go ahead and set the IP address. The interface, so it will say interface has no IP address, and it will go ahead and set the IP address on this interface. Else, if it hasn't got an IP address, and there isn't an IP address on there, sorry, if there is an IP address on there, it will go ahead and set the IP address. If there is an IP address, it will automatically say no, unable to set the IP address, and that's that's the approach that it takes. So what's happening, as you can see, is this is an imperative form of function form. We are essentially telling the function to do this imperatively, which is we are guiding it, we are specifically telling it and how it should create this, how it should push this configuration, so how this function should specifically declare these functions. So it's, as you can see, it's two different approaches. One, we're just focusing on the only results. We're specifically telling it to go ahead and push those configurations, regardless of what the case may be. And we're not concerned about how it does it. We're just concerned that it does it. And on the second one, on this class, you can see we are concerned with how it sets the IP address. We are concerned with whether there is an IP address already set on the interface. And if there is an IP set on the interface, then we're simply telling the program, no, forget it. Do not set it. But if it is, if there isn't an IP address, to go ahead and set the IP address, and that's how it's doing it imperatively. So we're actually guiding the function along, and we're telling it, we're basically providing it with the procedure that it needs to set the IP address on that interface. So that's the summary really of the difference between a declarative style and imperative style. Now, which one is better? I think. I mean, there's a lot of arguments. One is better than the other, or and so forth. But to be honest, with you, I think, I mean, uh, Python is an object-oriented programming language. Subsequently, I think we know a lot of people don't tend to use classes or attributes, and they just focus on functions. I believe that you need both. I believe you need declarative as well as imperative in network automation. And remember, we are talking here in terms of, in the context of network automation specifically. So everything that we talk about in relation to Python or programming, it's in the context of network automation. Thank you for coming to my channel.